is the doubt here?
Can you explain this question, sir?
So this is a table surface in which we are dragging the rod. The table surface is rough. So what is the angle at which it will be dragged? So question you can think like this. There is a table in which some L-shaped rod is kept. You tie this end with a thread and start pulling the thread towards right. So it will become like this. So what is the angle made by this alpha with the pulling direction when it is being dragged in this horizontal surface? This is the question. Did you understand the question?
Yes, sir.
Now, how to do this? So if we see the top view, we have something like this. This L-shaped rod means 90 degrees. So if we consider this angle as theta, this angle becomes 90 minus theta. Now, what kind of force would you like to draw in the free body diagram?
Friction force, sir.
Friction. Now friction is acting at which point, or friction is acting at all the points? Is this entire rod in contact with the table?
Yes, sir.
So wherever there is a contact, there is a rubbing.
Yes, sir.
So friction will be acting everywhere.
Yes, sir.
So friction is a distributed force. In case the friction is a distributed force, what you need to do then? So you can, there are two ways. I'll tell you both the ways.
Yes, sir.
One way is to do the integration. So divide it into small parts. Whichever part of the rod is in contact with the ground, that part's weight will be balanced by normal force at that location. So let us take a small element. So by the way, this rod is of uniform linear mass density and the lengths are given as L and 2L. Let's say the linear mass density is lambda. So from this end, if we take at a distance of x, a thickness dx, what is the mass of this?
They gave it as only uniform rod, sir, so we can take lambda as mass per unit length, then write it as lambda dx.
So what is the weight of this?
Sir, lambda dx into g, sir.
So what is the normal force?
Sir, lambda dx into g, sir.
So what is the friction force?
Mu into lambda dx into g, sir.
Friction force acts opposite to the direction of relative motion. So if this rod goes towards right, the friction will be in which direction?
Sir, towards the left, sir.
Okay. Now, this rod is given to be moving with constant velocity. So any point on the rod will be an inertial frame or a non-inertial frame?
Sir, inertial frame, sir.
Will there be any pseudo force in the frame of point P?
No, sir.
What is the torque of friction on this 2L rod dx element? This friction force torque will be how much?
Sir, this friction is mu into lambda dx into g into cos theta into x. That's torque.
Hmm. So torque is mu lambda dx into g into cos theta into x.
Yes, sir.
Integrate from 0 to 2L. Integration of x dx is x square by 2. So 2L square by 2. So we get 2L square. Is that clear?
Yes, sir.
Now there will be friction acting like this also. Will this friction and this friction create same direction torque or opposite direction?
Sir, opposite direction torque.
So calculate the torque of friction on this rod also and do the torque balance. Tell me
Yes,
what is the value of theta you are getting.
yes, sir. Sir, I'm getting tan theta is equal to 4, sir.
Tan theta is equal to 4. So the required angle alpha, so this is 90 plus theta. So pi by 2 plus tan inverse 4. Will it come out to be pi minus tan inverse 1 by 4?
Yes, sir.
Same or different?
Same, sir.
Any doubt in this?
Sir, no, sir.
Now here, the shortcut is like this, that there is no need to integrate. Because here the friction depends on mass. Friction is mu mg. It's like mu times of mg. So mg is also distributed force. If you take a rod, want to talk about torque of mg, mg is acting everywhere. Mg is a distributed force. So we use center of mass concept. If mg is distributed force, mu mg is also distributed. In the sense, if this gets a m, if this part has a mg and there is a torque, let's say this has a mass dm. So force is dm into g. And all these parts will get the gravitational force in same direction. And the gravitational force is proportional to mass. So friction also is like this, that all of these parts will get the friction force in same direction. That is important, that friction is in same direction and friction is proportional to mass. In that case, we can use center mass concept and say that entire friction can be assumed to be acting one single point, which is center mass. So that you can do only because of two conditions, that friction force is proportional to mass for an element, and then friction force on all elements is in same direction because of translation. If it was rotating, then also friction will be acting in, because this entire rod, if it rotates about this point, all points will have velocity perpendicular to rod. So friction will be opposite. Are you understanding this funda which I'm telling you?
Yes, sir.
Okay.